Algebra scholars, I'm going to be going over some examples of problems where if you only see two terms, something that you can do is take out a common factor. Now, this is silly. I have three terms, but the point is that I'm trying to show you how to take a greatest common factor out. So if I look at these two examples, and again, if you just want to pause this to write that down, feel free to do so. I look at each one of these terms and I think to myself, what do they all have in common? So the coefficients are all divisible by 2. That's going to be a common factor. And then each one of these terms, this has 6x's, 5x's, and 4x's. So my greatest common factor in this first part is going to be a 2 for sure from there, and I need an x to the 4th. Okay, that's going to be my common factor. Now, when I divide this common factor out of each term, what's left goes on the inside of the parentheses. So 2x to the 4th times this will give me 2x to the 6th. And as you can see, that's x squared. 2x to the 4th times this will give me minus 8x to the 5th. So that's minus 4x. And then 2x to the 4th times the third term will give me 42x to the 4th. So that's going to be minus 21. That'll get me to 42. And I already have enough x to the 4th, so I don't need more. When it says in section 4.4, factor completely, then you look at what you have and you say to yourself, can I factor this anymore? Well, this one, no, but this one, yes. So you can still do one more step here, and that is you need to factor this trinomial. Remember these first two terms, x times x will give you an x squared. These two terms multiplied has to give you negative 21, but when you combine them, you get negative 4. So I immediately think of negative 7 and positive 3, because that'll give me negative 21, but when I add negative 7x and 3x together, I get 4x. So hopefully you can see why that is now factored completely. Second one, I'm going to take a look at each one of these terms. Again, I'm looking for just the greatest common factor. So what is common to all three of them? Well, I know for sure I can take out a 5 from each of the coefficients. Oh, let me use my green pen. I know I can take out a 5. And let's see how many m's I can take out. Here I can take out 2 and 2 and 2. Remember, it's got to come out of all of them. So my greatest common factor is going to be 5m squared. Whatever's left over will be inside these parentheses. So 5m squared times this will give me 5m to the 4th. That's got to be m squared. Minus 7d divided by 5 is 14. And if I have m squared, I want m cubed, I need another one. And then 5 into 245. Let's see for a second there. 5 into 20 is 4. So that's going to be a 49. Good. Okay, so this is going to be 49. And then m squared, it's already an m squared. Again, that's how to take out the greatest common factor, but section 4 is where we have to completely factor. So if you take out a greatest common factor and you still see something else that can be factored, you must do the next step. And so this is, I recognize this as a trinomial that I can factor. M times m will give me m squared. These numbers here have to multiply, give me positive 49, but combined to give me negative 14, and that's going to be negative 7 each. If you want to, you can even go the next step further and write this as a square, because it's the same thing times. So there you go. That is a GCF. Another pattern you should recognize from previous work is the difference of squares. If I see two terms, now we're still in two terms, and the first one is a square and the second one is a square, then it will always factor to this pattern here. So it'll be A and A to give you that first term. It'll be plus B and minus B, or minus and plus, it doesn't matter. And B being the second term. Because when you multiply AB here, you'll get positive AB, and AB here, you'll get negative AB, and the middles will drop out. So this pattern here, one way you can think of it is, what is A? So what is being squared here? Okay, so this is 5 squared, and this is x squared, which means it's going to factor as A is x, so x and x. And this has to be a plus minus, and B is 5. If you recognize that pattern, that's it. Easy peasy. Now for the second one, I've got a few more coefficients involved here. But still, for each one, you're going to figure out what is this being squared. Well, this is 4 squared, right? And this is x squared squared. So A is 4x squared, and this is 9 squared. So this is going to factor in that pattern. A is 4x squared. They both go here. Plus, minus, and then B is 9. And that's all you do. You recognize the pattern, and it goes further. Now, that's how you apply the pattern, but look, you can even do it again, because this right here is the difference of squares. So this 4x squared is actually 2x times 2x, and this 9 is a 3. So what you can do actually is do one more step. You'll have 4x squared plus 9 here. You can't break that down anymore. But this one is going to be 2x plus 3 times 2x minus 3. So you must keep going, actually. Just wanted to show you how that broke down. And that is the difference in 4.4. We have another couple of special patterns. You've got the sum and difference of two cubes as well. So it's the same thing as here. You look at each term right here. You figure out what's being cubed, and it's always going to break down into this pattern. So you just have to remember this pattern. Here, I've got x cubed plus y cubed. So this is x times itself 3 times. This is y times itself 3 times. And so you're going to, like I said, follow this exact pattern. So here, a is x, and it's plus b is y. That should be on the outside. So that's where your x plus y comes from. Now, the second part of the pattern is this. It's going to be your a term squared. So I have x squared. It's going to be minus, so it's the opposite sign, a times b. So this is xy. And then I've got a plus, and then I have the b term squared. So b is y squared. That's all the amount of work that is required. You don't have to do anything else. Unless, of course, you can factor it more, but usually you can't if it looks like that. Same thing for this second example. You need to be able to recognize that this is 2x times 2x times 2x. It is a cubed. And then 27 is 3 times 3 times 3. So if it helps, you might want to write a little list of cubes on the side of your paper like we sometimes do. But again, all you're going to do is follow this pattern. And I did the plus twice, and maybe I should have done the minus, but you just follow exactly this pattern. It's the same in the a plus b, the same sign. If it's minus, it's the same sign. The next sign in between, they're opposite. Okay. And then at the end, it's the same again. So it's for the plus, minus, plus, and for the minus, it's minus, plus, plus. It's called SOAP. Anyway, so to follow this pattern, I'm going to do a plus b on the first one. Here's a, here's b. Then I'm going to do a squared, which is 2x. So 2x times 2x is 4x squared, minus ab, minus a is 2x and b is 3, so that's 6x. And then plus b squared is 3 squared, so that's going to be 9. And I'm looking at this, I don't see anything common. That is the pattern. It is pretty much done for that. Okay, I'm pretty sure, yep, I'm going to make the end of this and we'll do some more examples in class, but that's the basic 2-term video.